Hey there, everyone. My name is Ryan Schuel. Welcome to my channel. So in the project today, I want to take a look at how we can clean up really messy data. So I have a messy CSV file. I grabbed this CSV file from Kaggle.com, right? They have all kinds of little data science projects that you can try out and test your skills and fiddle around with, right? So the data actually comes from here. If you go over here, you'll see the file that you can download. You can download this exact file that I'm working with. I'm going to give you all the sample code here that I'm using. So there's the download file. You'll have the sample code here. I'll save this when I'm done with this, and you'll have everything you need to go ahead and do your own data cleaning exercise. And this is very important, actually. If you are a student in some kind of academic environment, your professor will probably go easy on you, especially in an intro class like 101 or whatever, and they're going to give you a very clean data set to start working with. In the real world, you never see clean data. I have been doing this for 20 years. I've never seen clean data in my life, right? You always have to embellish your data, enhance it, refine it. Refine is just a fancy word for cleaning. You always have to clean it and refine it and get it prepared to be fed into some type of machine learning model, so the machine can be trained and tested and used to make predictions, or at least if you're reporting on the data. Maybe you're not doing machine learning, maybe you're just doing some type of reporting, maybe you're a business analyst, maybe project manager, maybe junior data scientist, maybe just analyst, maybe you're just a student and you're just having fun with the data, right? I can pretty much guarantee you 99% of the time you're going to have to do some type of data cleaning and enhancement to just get the data into a good state that you can actually use it, right? If you feed garbage into a ML algo, short for algorithm, it's going to be garbage in, garbage out. The algorithm is not going to clean the data. It's not going to refine it. It's not going to enhance it. It's not going to fill in missing values. In fact, if you feed in missing values to most machine learning algorithms, it's just going to die right there on the spot. It's going to shut down and throw an error, and it's not even going to continue. Now, some of them will actually process the data, but that's the exception, not the rule. For most algos, you have to feed in clean data or it's just going to crash immediately, right? So let's take a look and see how we can clean up the data. How can we do transformations, exploratory data analysis, it's abbreviated EDA. How can we pre-process the data? How can we deduplicate the data? Sometimes you have duplicates. I worked in a company before. They made a mistake when they loaded in data, so they had to reload it. There was a mistake the second time, and they even had to do a fourth iteration of a data load in some instances. So they didn't know. This is hilarious, so I'm not going to spend a lot of time talking about this. They know which was which. So sometimes you had to take the data and just present it as is. Sometimes you had to divide by 2. Sometimes you had to divide by 3. Sometimes you even had to divide the data by 4. Can you imagine if you tried to show your clients some financial information about Apple and everything was stated 4 times higher than it was supposed to be? That's absolutely insane, right? But they couldn't fix it. They couldn't figure out what was what. I didn't stay at that company too long. But the point is, like, you have to have good data. You have to have integrity on your data. If you don't, then I can't predict what's going to happen. I don't know what the outcome is going to be, but it's not going to be good. So let's take a look and see if you have duplicates, missing values, inconsistent date formats. I've seen dates sometimes. They'll come in dozens of different formats. Sometimes it's made day, month, year, month, day, year, year, month, day, year, day, month. The year can be 2 letters. It can be 4. Our characters, not letters, right? It can be 2 numbers. It can be 4. Sometimes you'll have the month and the day. Sometimes it's a day and the month and the year is implied. There's all kinds of different stuff, right? So let's take a look and see how we can standardize all of our data and just have a better, more comprehensive understanding of what we're dealing with. So I'm going to read in the data right here. It comes from my desktop, and I have 120 rows and 12 columns. So it's always row, comma, column. Whenever you look at this stuff, a data frame is always row, comma, column. Fortunately, Excel is the same, so you don't have to relearn anything or redo anything different. And as an aside, if you have an R in front of your path to your data over here, you can use a single backslash. This is called the escape character, right? And you can read that in, and it works just fine. If you just want to use the R, you can use just 1 backslash. So I forgot why they did this. I think back in the day, Linux or something used a backslash as an escape sequence, but Windows had already reserved this for something else, and these teams didn't talk to each other, so it had different meanings. in two different enterprises, right? I think in Linux they did it one way, Windows did it the other. Anyways, you can get away with the R and a single backslash, or you need the double backslashes if you don't have that. So here's 120 rows, 12 columns. This is what the data looks like. So we can see the object of the data. This is the type. This is object. Age is actually a float. That should probably be an integer. I can't think of too many times you would want age to be a float, although maybe, but that's highly unusual. These are objects. So salary can be a float. That's fine. Email should be an object. Phone should probably be an integer. I think that's fine. And then we have some basic statistics. This is called describe. DF info. So this is some basic information about the info of the data frame, and describe will give you the top, mid, standard, min, max, things like that, right? So we have 1,020 rows, unique 1,020 for employee IDs. For first name, we only have 8 unique first names. That's interesting. 8 last names. Age, we have some nans. And then we have the mean, standard deviation. Anyways, these are basic statistics that say describe. It's describing the data frame. So here I say print data frame shape, drop any duplicates, and then print data frame shape again. So there are no duplicates. We started with 1,020 rows, and we finished with 1,020 rows. So nothing was dropped, okay? So that's fine. We have no duplicates. Now we want to get the first name and strip off the title, the string title from first name, last name, and from email address. So let's see what it looks like originally. If I go back over here, oh, I didn't do that. Okay. I was thinking like, why didn't that come up? Okay, that's why. Okay. So last name, we have Davis, first name Bob. That looks okay, but we should probably make sure that there's no leading or ending white space or characters in there. And what else? What else did I put down here? Email, so strip out anything from the email that doesn't belong. Again, looking for beginning white spaces or blank spaces. Okay, I think that's fine. I think that looks fine. The next step here, string contains email. So we're making all these emails regex equals true. So this is at example. So we have to have at least an ampersand and a .com, or it has to follow that convention. Maybe at google.com, at microsoft.com, it has to have some kind of standardization around the ampersand and a dot something. This could be .net, .org, something like that, but it has to follow some type of email convention. This phone number looks pretty jacked up right here. And then we have negative numbers and we have no hyphens. So that looks weird. Performance score. We don't actually have a score. All we have is average, excellent, good, poor. Rather than being numeric, this is a character type, and we can confirm that right up here. So performance score is an object, right? It's not an integer. So it's not int and it's not a float. I wouldn't expect it to be float, maybe integer, but in this case it's object. I think that's okay. And this remote work is Boolean. You can see BOOL. So remote, true or false, yes or no, on or off. That's all it's doing right there. And valid email. Okay, so anything that is not valid email, we're going to drop it, but we're going to make an attempt to try to convert everything to become a valid email. Okay, so it has to have this ampersand right here, and has to pass this email test, regex equals true. So let me get my mouse. What is it doing here? Okay, let me go over here for a sec. Trying to select something, it won't let me do it. Okay, there we go. All right, let me just do a quick Google search here. Email validation. So Google email validation. Let me put this in. So this should be the standard way to validate an email address. There's at least one conventional way, the regular expression. So Google gives us this right here. It's designed for email validation. Here's a simple breakdown. It tells you step by step. I'm not going to go through all this. If you don't know what this means, I would encourage you to take a look. If you don't care, I guess it's okay. But you have to just understand you have to follow this format. And if you already know it, that's fine too. So we follow that format and regex equals true. So that line looks fine. Email is fine. Phone number as type string. String replace any \d. Do we have a \d over here? We do not. So I don't know all these regex patterns. I recognize some of these. The more you know, the better. But nowadays with Google and with ChatGPT, you don't really have to memorize these things, right? You have to just have a basic understanding. When we're validating this phone number, we want to make sure this is a string. There is a character replace. It looks like D digits. Oh yeah, this is a digit, right? And enforce length. So it has to be 10 characters, right? So if we look at this over here, here's the phone number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 characters, right? So on the first line under phone, I have 10 characters and they're all digits. If you go back and look at the original, that was kind of jacked up. It actually was digits, but they're all negative. Okay, so we strip off the negative, make this positive, and there's 10 digits. So that's what that is doing right there, right? So we have the first name, the last name, email, and then the phone number. So we're doing 4 sort of data fixes right here, or data cleaning exercises in this one cell. Control Enter. Let me take a look. So there's no spaces in the first name or last name. That's fine. Let's look at the email address. Okay, so all of these are valid email addresses, and the phone number is now a bunch of digits. That negative sign is gone, and we have 10 digits, no more, no less. So salary now. Let's take a look at salary. We have dollars and cents. I think it's okay. This could be an integer or this could be done in pennies, right? Here's the float part. It's a decimal. So we have the float. The U.S. government just announced that it's getting rid of pennies permanently. It's not going to print any more pennies. I think the problem was it costs a lot to make a penny. Make a P-E-N-Y. Okay, so the mint spent 0.369 cents to make a penny. So that makes no sense, okay? Pun intended. It makes no sense to make sense if it costs 3.69 cents to make a cent and it's worth 1 cent. You're literally just destroying money. It's called capital destruction, okay, guys? Capital destruction. What we want to do in the finance world, I've been in the finance space for over 20 years, we want capital creation. We want to create capital, create more capital, create value, create wealth, create affluence, right? If you have capital destruction, you're taking something that's worth a lot and basically destroying it and making it worth a lot less, making it worth maybe nothing, right? If you keep going at that rate. So that's why the Treasury decided to stop producing pennies. It takes close to 4 cents to make something that costs 1 cent. That's capital destruction. That's nonsense. Don't do that, okay? Surprised it took them that long to wake up and to discover that, but at least they did. So congratulations to the U.S. government. So now we're looking at salary. So my point is you could make this integer over here. I'm going to keep it as float. I think we'll still use float, but pennies now are basically going away. The U.S. Mint is not minting any more pennies. I think it's the Mint that does it, not the Treasury. I think the Mint would create pennies. So they're not doing it anymore, thank God, because it costs almost 4 cents to create something that makes the value of 1 cent. So that, again, that makes no sense to make sense, right? So we could either make this integer or keep it as float. It doesn't matter. It's really up to you. The join date now is coerce. So using this as a date where the person joined the company. If we go back a little bit, join date looks okay over here. Here's the first case that we see of join date. These look okay, but I'm just going to force it to be a date down here. So PD to date time. This is the date field in this data frame. So here's the data frame. DF is data frame. Join date is this field in the data frame. And I just want to force it to be a date. If there's any errors, we say coerce or force, kind of rhymes with coerce, force it to be a date if it's not a date. Now in this case, I think everything is a date, although it does have a backslash. So for /2 or /. I think this is /. I always get those mixed up. I think forward because it leans forward, and this would be back. I think this is a backslash over here. Right, I think this is a /. Could be wrong, but that's what I think that is. So we're taking everything that's a / and converting that to a hyphen, just again to standardize all this. So we have the year, the month, and the day, and this is just a standard pandas date time format. We had the month, day, year. So pandas says to be correct and just to standardize everything, it's day, month, year. And that's fine, okay? We're just getting everything standardized and cleaned up. So is null, mean value, sort ascending equals false. Drop anything that has a threshold greater than 70%, or keep anything greater than 70%. So we're going to drop rows with too many values missing. Okay, so if we have a column with a lot of missing values like age, status, join date, salary, email, anything, if we have more than 70% missing, this is a lot of missing data. We can't interpolate, we can't backfill, we can't forward fill. These make no sense because we have too many missing data points. If you took the inverse of that and you had 30% missing and 70% filled in, that is okay. You can interpolate missing values. You can use the mean mode if it's numeric. Um, you can forward fill if it makes sense. Like if somebody has a missing join date or date of birth or something like that, you wouldn't forward fill that. That would make no sense. But if it was really missing a join date or a date of birth, um, you'd probably have to drop the records because you can't interpolate somebody's birthday. You can't interpolate the join date when they join a company, right? You'd have to somehow get people to fill in those dates, right? Post something on the server, send them an email with a link. They click on the link, log into the portal, and then they update their join date or their birthday, whatever it is. That's the only way to collect information from people. We can't interpolate that, right? But for some things, like if you just wanted an average grade, average age of a group or of a team, I guess you could do that. I don't know how useful that would be, but if you were rolling up the data into a different hierarchy or a different level and you just wanted the average age and average salary of the group, you could certainly do that. Maybe that's a requirement. But if you go to the raw record, you can't interpolate somebody's age or their join date. It doesn't make sense. But we can go ahead and make sure that the age, instead of being a float, is actually an integer. So here is 25, here's 32, here's 32, here's 25, 25. So this shouldn't be a float. This can be an integer. Salary can be a float. That's totally fine. And remote work can be Boolean. So let me hit Control Enter to refresh the cell. And it says something's wrong here. Let me look here. Did I get the one before that? Maybe I didn't get the prior step. Yeah, I think I missed a prior step. Okay, so it has to be clean before you feed it into the next level of cleaning. Here, this has to be structured and it has to be done in a certain order, right? So we do cleaning in iterations and step by step. So follow the steps here. Categorical columns is department, region, and performance score. So this is a category. Region is a category, all right, and performance score. Where's my region? Oh, okay. So we have department and region mixed together. We're actually going to split those out and create separate departments and regions. And the performance score is going to be a category. So a category is like small, medium, large, average, excellent, good, true, false. Well, this is more binary. Category could be DevOps, finance, some kind of title or some kind of label would be a category. And just to take a step back, I think I did miss something over here because we took, or is it department and region? So we took the original department region and split that into department comma region by the hyphen, okay? So anything that's on the right-hand side of the equal sign is the original state that this was in. The original department region comes to us like this, right? DevOps California. If you go back a step, DevOps California, I'm saying split that into the department and the region, right? So two separate things in the next step. So you have DevOps hyphen California. So you have department, region, split the string right here by the hyphen and split it into department and region. So we have two different categories there, department and region. Before it was just department, region all merged together. You can go over here and see the last step. The last column over here in this data frame is remote work. After remote work, we created these two new columns right here from this one column. So we split the string based on hyphen and created department and region just to make it easier to work with, to make it more split, and to make it more refined and more clean, okay? So let me go back here and redo this one and do this again. Let me go back and do a couple of steps. You have to do this in order, right? And if you get out of order, it gives a weird error. Okay, so let me go here. I'll go to the next step. I know this is correct. Run all above selected cell. Okay. And now it's fine. Okay. So there's a little trick. You can go to run all above selected cell. You have to be in the next cell after where you want this to run. So if you want this to be cleaned up here, you have to go back to the next cell below this, run that, and it goes run before all selected cell. Now, I just put this together pretty quick just to do this demo here. This is not bulletproof. So you saw an error. If I rerun this, I guess I'm going to get the error again. Oh, actually not. That's interesting. And over here, did I get it? What threw the error before? That's weird. Okay. Well, if you do see an error, I would encourage you to go ahead and figure out what's causing the error and actually solve it. In this case, I did this pretty quick last night before going to bed. So this is not bulletproof. This is not 100% like um, ready to go into deployment, into production, or something like that. Right? You want to do this in iterations, test different scenarios. Does this work under different stress tests? Does this work if it's um, loaded different ways or run in different orders? Right? You want to test for these things and make this really bulletproof. This is not. This is just a hack job I put together and I know it works, but sometimes if you do things out of sequence or in the wrong order, it could get a little jammed up and you get these weird errors. If you get that, I would say go back and you should fix that. I'm just doing a quick demo here, so I'm not too concerned about that. I know when you run the code in consecutive order, it works. If you skip around a little bit, maybe it doesn't work, right? So Control Enter to refresh this. So salary, I'm saying anything greater than 5,000 or half a million, okay, 500,000 or less than 20,000, we are going to kick these out. So detect invalid values, anything greater than half a million. So I don't think anyone at this company is making greater than half a million. I don't think anyone's making less than 20,000, but this is one way to look for outliers, right? And if this is wrong, maybe somebody meant to put in 20,000, they put in $20 or something. I don't think anybody's making $20 a year, so that should be fixed. This is more like an HR kind of data quality exercise. Age, quick sanity check, is anybody over 18 or less than 16? So if somebody is 61, and by the way, age should be calculated based on date of birth, but if somebody hard codes it, I can't prevent that from happening. You really should be hard coding a date. You should be hard coding, you shouldn't be hard coding an age. You should be calculating the age, but I've seen this, I've seen everything, right? I've been doing this for more than 20 years. Sometimes people hard code the age. If somebody was born yesterday and the age was entered yesterday, it's already wrong by tomorrow, right? Because the person's 1 day older. If yesterday was their birthday or today, now they're 1 year older, and this is already wrong and it's obsolete, right? Either here or here. So you should be calculating age, not hard coding it, but sometimes people do that, and that's okay. But if we want to look for anyone over 80 or under 16, this would do that for us, right? So it's probably fat fingered or entered incorrectly. And again, you should be entering age, you should be calculating age. So this is just a quick sanity check to make sure. Do we have anyone older than 80? Probably not. If we do, maybe we have to figure out why. Maybe it's the owner and they just refuse to retire. If it's just a rank and file employee and they're just hanging out, maybe we have to push this person out over 80, or find out exactly why an 80-year-old is still working there, and under 16 that might be illegal. So we have to deal with that, right? So just a quick sanity check to see, do we have people making over $500,000 a year? If this is a normal company, probably we shouldn't have that. If it's an investment bank or some some managing director at a big bulge bracket bank, maybe they're making more than that, right? But that's kind of a unique scenario. You're not going to see too many, and you're probably not going to see too many people making less than 20K. Although there might be, probably not. But if there is, you probably want to find that out and figure out why. So I took everything above and put this into a pipeline so we can do all the cleaning just in one quick go. This is all in one cell. So I have first name, last name, just like I described above, but instead of breaking it out into many different cells, everything is a one. So here's the email. This is a validation test for an email. Salaries, we are making sure that these are actual numbers, right? Making sure that we have a number there and not some kind of letter character, right? These should be numeric characters, not letter characters. Join date, department, region, again, stripping out any white spaces, splitting strings from department hyphen region into department and region, two separate columns in the data frame, right? Phone number, make sure these are actual digits. Backslash D is a digit. Salary, department, region, so median, mode. These are all numbers. Although department, I think, could be a character, it could be a string or mode. That is fine. Either way is fine. And we're looking for duplicate employee IDs. We should never have a duplicate ID. That should not exist. So let me run that quickly. Now we have everything just in one go in one self-contained pipeline called clean employee data. So this is a full cleaning data pipeline. Now again, this is not comprehensive and it doesn't include every possible scenario you're ever going to encounter. But these are the main things you're probably going to see, at least in a basic data set. Now, if you're working with data and you have different columns, very likely you're going to have different columns in this. Just use this as a guideline. Okay, this is not the gospel truth, but I think this is going to cover a lot of things you're going to see day to day. If an exception pops up, you just deal with it, put that into a separate line, maybe create another line down here, exceptions or whatever, right? And you put in the business logic for your new data set right here, or whatever it is, right? Let me hit Control Z a couple times, go back. I don't need that right now, but everything can be in a self-contained pipeline like you see right there. Now here's an interesting thing to look for missing values, NAND per column. So is NA.sum, if anything is a NAND, we're going to sum it up in these columns. I want to see which specific column has an NA, Control Enter. None of them do. If you want to do everything all in one go, you can do .sum. So it takes the sum of a sum. So one.sum will sum up all the missing values. So here's missing value, .sum, it gets all the missing values per field in the data frame or feature. These are called features or columns or fields in the data frame. Okay, and if you do .sum, you take the .sum right here and you sum up all these. If you sum up all the zeros of all the zeros, you get one single zero, like you see here, so all zeros. So you can do it either way, right? If you want to see where the missing values are in detail, use this technique, .sum. If you just want to see if anything is missing in the entire data set, .sum tells you 0%. So we are good to go there, guys. We look pretty good at this point. So here's a missing report. I'm going to do this real quick to see if anything is missing. Is NA.sum. Remember, one.sum, if you do .sum, it takes everything and comprehensively sums up, and you'll get one single zero. If you do .sum, you get the missing per column. So here's no missing and missing count. Total rows, 1020, percent missing 0. Object, these are mostly object. This is date time. This is a date. This is salary, float. Most of these are object. This is Boolean. And number of unique values. So 1020, every ID is unique. If you saw anything less than 120, you would have a duplicate, and you have to look into that. You should never have duplicate ID, employee IDs or IDs for anything. Like you would never have duplicate credit card numbers, email addresses, phone number, IP address, employee ID. These are always unique. There is no exception to that rule. Okay, here's the data set right here, Kaggle.dataset. I am going to take this right here, save as HTML. I'm going to save this HTML file and share it with you guys. When I post this video a little bit later today, I'm going to post a video and I will post the code so you have everything you need. Again, not comprehensive, but I think that's a very good start to clean up a lot of messy data sets. And as you go, you'll probably encounter a couple nuances, a couple new things that just pop up. Go ahead, create the logic that you need. Use Google if you get stuck, or ChatGPT. Put it into this pipeline right here. All right, save it. Hit the little save button right there. And last checkpoint, 41 minutes ago, 2 seconds ago, that should be fresh. Then you have your new pipeline ready to go, and you can do this in a couple of seconds. Control Enter to run this. Your data frame is cleaned up in less than a second. It took a fraction of a second, and you're good to go. So that's it, guys. Hopefully that was beneficial and useful, and what else? Beneficial for you. I guess that's all I'm trying to say. That's it. How to clean up a messy data set. This is a CSV file, but it could be anything. It could be Excel. It could be a table in a database. It could be a text file. It could be a Parquet file, anything like that. HTML file. It could be a XML file, right? Anything. This will take your data, clean it up, and prepare it for anything you need to do at the next phase, either reporting, machine learning, some kind of data science experiments, whatever you need. Make sure you have clean data before you start your experimental exercises, and you're good to go. If you're throwing dirty data in there, good luck, guys. Good luck. I don't know what to tell you, but I can tell you it's not going to work. I don't know what the outcome is going to be, but it's not going to be good. So that's it. I'm going to wrap up here. Thanks for your time, and I'll share the code, and I'll share the video with you a little bit later today. Until next time, thank you so much, and I'll see you soon. Bye.